Hello, my name is Erdem Topsakal. I'm the editor-in-chief of IEEE Antennas and Propagation Society Digital Communications. I'm very excited, honored, and privileged that we have a special guest today, Professor Susan Hagness. Thank you for your time, for being with us today.
Thank you, Erdem.
We all have I would like to start with a question. We all, and probably will take you back a little bit, we all have our own stories as to how we started, in engineering, academic life and all that. So can you please share with us your story?
Absolutely. So we all have those pivotal moments. And for me, it's all about the people in my life along the way that I think back. I'm so grateful for the influence they had in my life. So I have to give a shout out to my junior high school algebra teacher who made math a thrill. And I also have to give a shout out to a professor at Rose-Hulman Institute of Technology who welcomed me into his classroom my senior year in high school when I had run out of classes to take at our local high school. So I was able to sit in on math classes that he was teaching. He was also a close family friend of ours, and he was an incredible mentor. Okay. So he was the one who kind of put two and two together for me and said that, if you like math, if you like physics, you should try electrical engineering. It was his undergraduate discipline. And I ended up going into electrical engineering just based on that recommendation. I didn't have any engineers in the family. It was really just roll the dice kind of situation. But I loved it. I absolutely loved it. And what made it extra special when I went up to Northwestern University as an undergrad was that I started off right away pursuing research with a dear mentor. So again, thinking about the people along the way that nudged me in certain directions that helped me get to where I am now. That dear mentor was Alan Taflub, who, as many in the community know, was a pioneer of FDTD.
Yes.
He was an award-winning educator, so I had the good fortune of taking several classes from him, and he welcomed me into his research lab. So I had the undergraduate research experience. I wasn't completely sure about grad school, but I had taken an industry internship between my junior and senior year in college and decided that based on that experience, I loved research too much to stop at that point with my education and go into industry. So I continued on with my PhD studies with Alan Taflub and was able to work on FDTD theory and algorithms at a time period when we were building up some of the fundamental building blocks of FDTD algorithms, expanding the capabilities of this simulation tool to allow us to tackle problems that were more complex than sort of the basics. So, this was FDTD in the early 1990s. We were getting into modeling interactions of electromagnetic waves with dispersive and nonlinear materials, expanding its applicability to optics and photonics, and that was the focus of my PhD. That was also the era of running FDTD codes on really big machines. Yeah. So we had the luxury of running our simulations on Cray supercomputers at the time. It was also the era of having the big, bulky silicon graphics workstations on the top of a desk. So fond memories of some of those days. Then, as I was finishing up my PhD, I had to make the decision of what next. And for me, I honed in on an academic career after having the opportunity to teach a brand new course at Northwestern University at the time that was introducing engineering to first-year undergraduate students. So I ended up teaching a course called Engineering Analysis. I was part of a teaching team. The team included a number of extraordinary instructors in the McCormick School of Engineering and Applied Science there. And so I was learning from some of the most talented teachers on this planet, and I got hooked. I got hooked on teaching. So I joined UW-Madison in 1998 after I finished my PhD, and I just finished 25 years.
Wonderful. great story. So my next question about your research, of course, as an academic, we do many things. We do teaching, we do research, and all that. And I've known you for some number of years, so I know, you have been. Your main research has been in medical applications. So can you tell us a little bit I know that you branched into some exciting other areas recently. So can you tell us a little bit about starting with your early career, some of the things that you started doing, and then the research evolved, different areas and all that.
Absolutely. The great thing that I tell my students about getting a PhD is that we are learning to tackle interesting problems. And the problems that our students are working on right now, they will be working on problems 25 years later that don't resemble anything that they were doing for their PhD. We've all been through that.
Absolutely.
So I have been amazed at how my research directions have evolved over the years. And again, learning from that experience, what I tell my students now is that one of the best things you can do is just be open to those serendipitous moments when you encounter someone who is looking for the kind of expertise that you might have, working on a completely different problem, those collisions where you have the opportunity to put together expertise to do something really amazing. So our research evolved through a variety of biomedical applications of electromagnetic wave interactions with the human body. At this point, when I look at more recently what we've been working on, the way I describe it is it's radio science meets smart medicine and smart agriculture, because we've had the opportunity to work on problems that leverage the electromagnetic interactions with tissue, both human and animal tissue as well as plant tissue. So we've developed adaptive, autonomous, technology-enhanced tools for a variety of applications in both medicine and agriculture. Over the past 15 years, one of the workhorse tools that we've had is dielectric spectroscopy. We've had to learn what the fundamental properties are of a variety of different tissue types under a variety of different conditions. So different temperatures, as a function of thermal damage when we've been looking at electromagnetic wave interactions with tissue that's undergoing treatment. We've been able to incorporate machine learning technologies into some of our sensing applications. So for example, we've developed machine learning enhanced radar techniques, remote sensing techniques for assessing the yield of cranberry crops. Mm-hmm. We have a lot of those in Wisconsin. And another major theme over the last 10 years has been developing novel antennas for performing in new ways in the human body to specifically treat cancer in a variety of locations. So we've worked on balun-free designs, we've worked on flexible antennas. This has been really exciting work for me because the innovations we've been able to pursue in antenna designs has made it possible to route a very small, narrow diameter, flexible antenna through a robotically directed or assisted catheter to get to the site of a tumor without having to go into that tumor site through like a line of sight path. So that's been exciting. We've been working on knowledge-enhanced beamforming, non-invasive techniques for hyperthermia treatment. So, so many of the problems that we worked on have come to fruition by partnering with other experts. And I think that's one of the most exciting things about our field is that we have these opportunities to pursue really meaningful collaborations.
Great. We had mentioned about the students, and I know that students play a big role in our lives, especially in your life. Yeah. And then having seen you as a mentor, bringing all your students to many conferences and, how they speak so highly about you. So tell us a little bit about the book. So we have this book, Electrodynamics, which has received tens of thousands of citations. And how were you involved in the book with Professor Taflo?
I was so honored to have the opportunity to join him on the subsequent editions of the now infamous computational electrodynamics textbook. He wrote that first edition on a small screen Mac in the basement of his house.
Oh, I did not know that.
And we were graduate students at the time, and I remember him just spending countless hours on that. I got involved in subsequent editions. Again, grateful to him for that opportunity to partner with him in expanding. This was an era when FDTD was undergoing significant updates and enhanced capabilities, and so in subsequent editions we were expanding, bringing in additional authors to write chapters on some of the latest algorithms and concepts. I had the opportunity to move the book in a direction that made it really suitable for instruction. So we added more problems at the end of the chapters, wrote up extensive solutions, provided sample codes. It was really a gift from Alan to bring me in on that project. But I absolutely have to give him the credit for the initial tone that it was and the incredible value it's provided to our society.
Well, indeed, a great book, a great man, and great collaboration. Of course, I also use the book, and it's indeed a great book. One of the things that we have to do as academics is to basically recruit students, undergraduate students in our labs and graduate students and all that. And I hear from colleagues most of the time how difficult it is actually to recruit students, let alone underrepresented minorities and all that. And you are pretty much a role model. And then I see a lot of students around you, especially female students. And can you tell us a little bit about how do you see it, how did we evolve from, let's say 10, 20 years ago versus right now? And we have yet to do a lot of things, basically. We're not there yet. Mm-hmm. We have a lot to do. So can you tell us your approach to it? What kinds of advice can you give to other, colleagues out there, and all that? How do you see the whole, recruitment and retention, specifically, underrepresented minorities, women in
Sure.
APS?
Well, I'm really hopeful. I'm very optimistic. We've seen tremendous progress in my lifetime, in my 25 years at UW-Madison. And just to give some perspective on that, when I started at UW-Madison as an assistant professor in the Department of Electrical and Computer Engineering, I was one of 2 women faculty. And fast forward to today, 25 years later, I have been serving as the department chair for the last 5 years, and we've been fortunate to do a lot of hiring over this time period. So fast forward, we now have 13 women faculty in our department, so we're more than 25%. So it's examples like that that are signs of tremendous progress. Our PhD program in ECE at UW-Madison is now 25% women. That's double what it was a decade ago. So how do we get from point A to point B and see these signs of progress? I mean, there's still a lot of work to be done, but we're making progress. So I think first and foremost, we have to be fostering an inclusive environment. We are never going to make the kind of strides we seek to make with respect to diversity if we don't have a welcoming, inclusive environment for those students that we recruit into the field to experience. So first and foremost, it's not about recruitment, it's about retention. And if we have a good environment that retains students because they're thriving and they're flourishing, then we will attract more and more students. And I've experienced that in my own group, which coincidentally right now just happens to be all women. All my PhD students are women, which one could argue is not a diverse environment, but kind of in the flipped sense. So how do we foster an inclusive environment? We need to be aware of implicit bias, unconscious bias. We need to be proactively welcoming students into the field. I think all of us who have gotten to this point in our career where we are, this is our opportunity to pay it forward. And that's a call for all of us, men and women in the Antennas and Propagation Society, to really step up and go the extra mile and advocate for our early career colleagues at all levels. And I'm thrilled to see the success that we're making within the society. Advances like a Young Professionals Ambassador Program. I'd like to see us do more with bringing students into the research community, into this professional society, even before they get hooked into our graduate programs. So doing more at the undergraduate level. Again, beyond bringing the students that are already doing research, let's bring in students that are from our classes.
Exactly.
And let them see the excitement of the research that's taking place and being shared at conferences.
I totally agree with you, because most of the time when my colleagues ask me, how do you have that many local students come into your group? Because I tell them that actually I moved them earlier in the career from my classes, undergraduate classes mainly, and then, they ease up their way into the PhD program, most of the time graduate and all that. My last question is about, IEEE and APS, and you're an, IEEE fellow. What was your journey in the, getting involved in IEEE and Antennas and Propagation Society activities? What advice would you give to undergraduate students, their involvement in the society, with the conferences and with, other things and all that? Anything you may share with us, your own experience and your advice, to the students.
Well, I wrote up an article a couple of years ago for the Women in Engineering column in the Antennas and Propagation Society magazine. And I focused my thoughts for that article about the importance of mentoring. And the advice that I have for students and more junior colleagues is to ensure that you have what I think of as a constellation of mentors. So it's a process of diversifying a portfolio of mentors, if you want to think of it as a portfolio. Making sure that you are seeking out mentors at not only senior career stages, but also peer mentors. Seeking out mentors that are both of the same gender as you and the opposite gender. Seeking out mentors that are in your own department, in your own college, but also at other universities or in industry if you're in industry. So diversifying across companies. I have benefited so much in my career at every stage of my career from having both peer and senior mentors who have been supportive. They've given me advice. They've been outstanding sounding boards. And, I refer to paying it forward as being our calling now. And I really mean that because, you mentioned IEEE fellow. There were so many senior folks in our field who along the way, very early on, just went the extra mile to nominate me for an award, look out for me, get me involved in AdCom. I've had a lot of opportunities to be part of leadership roles, and so forth and so on. It just kind of builds momentum.
Also for students, we have student opportunities.
Student opportunities to get involved, absolutely, yeah. Whether it's the travel grants or volunteering. We all tell our students, spend time in the sessions, but also spend time in the coffee break and the hallways, the foyers, to be meeting people and we just need to keep looking out for them and introducing them to the wonderful people in our community.
Wonderful. Well, that concludes my interview with you. Thank you so much again.
Thank you for the great questions.
Thank you. Well, that wraps up our interview with Professor Susan Hagness. And if any of the students out there are interested in the exciting things that Professor Hagness is doing. Reach out to her. Madison is a beautiful place. I've been there, Wisconsin, Madison, and she's an excellent mentor. So you can find her email address online. Well, thank you so much again. Until next time, be healthy, be happy.